In this set of notes, we're going to talk about the difference between vertex form of a quadratic equation and standard form. We're going to review some of the things that we've learned about vertex form and our expectations regarding quadratics, and then we're going to learn how to graph using standard form by finding the axis of symmetry and building around. So first, remember that vertex form is y equals plus or minus a times x minus h squared plus k, where your vertex is the point hk. And the parabola, some of the things that will determine the way it looks are if it opens up or down based on the plus minus, how wide or narrow it is based on the absolute value of a, the left or right shift based on the h value, and the up or down shift based on the k value. Standard form of a quadratic equation is going to be y equals ax squared plus bx plus c. So a will always be our coefficient of x squared. That can be positive, negative, bigger or less than 1. It just can't be 0, because if it were 0, this term would drop out, making it linear. B will always be our coefficient of x, and c will always be our constant. So let's look at vertex form. So if we were going to graph y equals negative 2 times x minus 1 squared plus 5, we would start with our vertex, which would be 1, 5. Now, some expectations that I have for this parabola is that I would expect it to point downward because the a value is negative, and I would also expect it to be narrower than the parent function. There's also a horizontal shift. It's going to be going to the right one space compared to the parent function. And we can see that here because our parent function would have started at the origin. There is a vertical stretch where it's going to be 2 times. There's also a vertical shift, which is up 5 spaces. And again, we can see that on this vertex. It's going to open downward because of that negative. And the equation of my line of symmetry is going to be the vertical line x equals 1. And if I were to draw that here, it would look like this. And then the max and min value of this function, the highest this parabola is going to reach. So since it's the highest, it's going to be a maximum, and it's a maximum value of 5. And so now to finish this graph, because I'm not sketching, I'm going to pick 2 points on either side of the vertex. And so the easiest point on the left side of my vertex would be where x equals 0, and that's going to be a symmetry point with x equaling 2. And then if I continue building out, then my next 2 sets of symmetry points would be negative 1 and 3. And so now I'm going to find my y values by replacing one of these 2 x values for my symmetry points into my original equation, which was y equals negative 2 times x minus 1 squared plus 5. And so I might do 0, y equals negative 2. Now if x were 0, that would be negative 1 squared plus 5. I want to remember to follow PEMDAS. Negative 1 times negative 1 is going to be 1 plus 5, and then negative 2 plus 5 would be positive 3. And so both my x values of 0 and 2 have an output or a y value of 3 because they're symmetry points. And then I can come over and add these to the graph. And so my expectations are correct that it's facing downward. Next, I can choose to replace x with either negative 1 or 3 because they're going to have the same y value. I'll probably use 3 since I won't be dealing with a negative inside the parentheses. So 3 minus 1 squared plus 5. So 3 minus 1 would be 2. Remember to follow PEMDAS, so we're going to square 2 to get 4, which would be negative 8 plus 5 for a y value of negative 3. And so that's going to bring me here on my parabola. And again, I can see that this is doing exactly what I want it to do. It's a downward facing, narrower parabola compared to the parent. So the beauty of vertex form is that it shows you the vertex. When something is in standard form, which is going to be that y equals ax squared plus bx plus c, it'll be this. It does not show me the vertex, and so I need to find the vertex. Now remember, one of the things we noticed about the vertex on the Jamboard last week was that the axis of symmetry passes through the vertex. And so what we're going to use for the vertex is we're going to use the axis of symmetry formula first. And remember, the axis of symmetry is a vertical line. It's an x equals equation. And this formula is opposite b over 2a. So we're going to identify b in our quadratic equation. We're going to do its opposite, and then we're going to divide by twice the a value. So understanding what a, b, and c represent will be pretty important. So first, in this quadratic equation here, I have an a value of 3, a b value of 6, and a c value of 1. A, b, c. And so if I want to find my axis of symmetry, I'm going to do opposite b, which would be negative 6, over 2 times a, where a is 3. So this would give me negative 6 over 6, or negative 1. So that means my axis of symmetry is going to be x equals negative 1. Now remember that this is my x coordinate of my vertex. My y coordinate of my vertex will be the y value when I replace x in this quadratic equation. So now what I'm going to do is I'm going to change x to negative 1, and we'll see what y will equal. So negative 1 squared would be 1 times 3 is 3, plus 6 times negative 1 is negative 6, and then plus 1. And now I'm going to add these together. So 3 plus negative 6 is negative 3. Negative 3 plus 1 would be negative 2. And so that means my vertex would be the point, negative 1, negative 2. Again, I achieved the negative 1 portion by using my axis of symmetry formula. And then once I had this x value, I replaced it into this quadratic equation to find the y value of the vertex. So let's try it on this next example here. So here's my quadratic equation, y equals negative 2x squared plus 12x minus 7. I can still look at my a value. A is still going to have the same effect that it did in vertex form. It's just that I can't necessarily see the horizontal and up-down shift. But this will still tell me that my parabola should be downward facing and should be narrower than my parent. So that expectation is still going to be true. So the first thing that I'm going to do is I'm going to use my axis of symmetry formula. X equals negative b over 2a, and I'm going to plug in these numbers. So my b value is 12, and so according to the formula I need to do opposite b, which would be negative 12. My a value is negative 2, and so I'm going to do 2 times negative 2. So this would give me negative 12 over negative 4 for an x equals 3. So that's going to be my axis of symmetry. And when I add that in my table, I'm going to put it right in the middle because I'm going to be building around that. So I can actually come over to my graph, and I can add my axis of symmetry of 3 as this vertical line here. So I know that somewhere along this line is going to be my vertex. I also know that from there my parabola is going to face downward and be narrower than the parent function. So my next step is to find the y value of my vertex here, and so to do that all I have to do is replace 3 into my quadratic equation. And so when I do that, I'm going to get y equals negative 2 times 3 squared plus 12 times 3 minus 7. So that'll be negative 2 times 9 plus 36 minus 7. It'll be negative 18 plus 36 minus 7. Negative 18 plus 36 is 18. And then 18 minus 7 would be 11. So my vertex is the point 3, 11. And so, of course, this is going to go off the graph, but that's okay. It's only going to go off by 1 because this is a 10 by 10 graph, so I can put my vertex up here. So my next thing is, just like we were doing before, we're just going to build around using symmetry points. So again, the only real difference right now is that I couldn't identify my vertex from this equation the way I could in vertex form. I had to go through this process first to find it. But everything from here is going to be symmetrical. So that means that an x value of 2 would be a symmetry point with an x value of 4, and then an x value of 1 would be a symmetry point with an x value of 5. And so I can replace, for 2 and 4, I can pick one of them to plug in here, and whatever y value comes out for 2, it will be the same y value for 4. So let's try it for 2. So this would mean that it would be y equals negative 2 squared plus 12 times 2 minus 7. So this would be negative 2 times 4 plus 24 minus 7, which would be negative 8 plus 24 minus 7. And so then negative 8 plus 24 would be 16. 16 minus 7 would be 9. And so that means when I replaced x with 2, I get a y value of 9. That will be the same output for when x equals 4. And this is good news, oops, this is here, because now my parabola is starting to trend downward like I expected based on that a value. And now I can do this again. I'll probably use 1. 1's an easier number, I think, to work with than 5. So negative 2 times, well, 1 squared is just going to be 1, plus 12 times 1 is just 12. And so that'll be negative 2 plus 12 minus 7, which would be negative 2 plus 12 is 10, and then 10 minus 7 is 3. And so again, I'm continuing to trend in that same direction here. Now the last thing I might do, just because I know it's going to be pretty simple, is my next point is going to be my y-intercept. I don't have any room in my table, but I know that along this line the x value is 0, and I can actually just look at this equation and say, well, if x is 0 here, this will go away. If x is 0 here, this will go away. And that's going to leave me with a y value of negative 7. And so I can just add this extra symmetry point here. Not that it's a requirement, but just like with a line, the more points that you have, the easier it is to graph. This is just making it a little bit easier to connect these points by adding that extra symmetry point. So let's look at example 2. I'm going to get you started on this one, and then you can finish this graph. So again, it's in standard form, so my a value is 3, my b value, careful on this one, it's negative 6, and my c value, although I don't really need that one right now, is 2. And so the first thing I want to start by doing is finding my axis of symmetry. And so to do that, I'm going to do the formula opposite b over 2a. Now in this case, since my b value is already negative 6, that means its opposite is going to be positive 6. And then over 2 times a, which is 3, that would give me 6 over 6 for an axis of symmetry of 1. And so I can come over to this graph, and I can add that axis of symmetry here. I like adding the line to actually show the axis of symmetry because it helps remind me that this should center my parabola when I'm graphing. So my next step would be to find the output when x equals negative 1. So I'm going to replace that here, that 1. So you're going to do that in a moment on your own. The next thing that you're going to do is you're going to add your symmetry points. So what's equidistant from 1 on either side? That would be 0 and 2. So the nice thing is 0 would be a really easy number to work with here. And then if I continue building, it would be negative 1 and 3. And so you might choose to use negative 1, you might choose to use 3, but remember they're going to have the same output. So start by finding the y value of your vertex and then build around your symmetry points. When you graph your parabola, use your expectations of your a value. So my a value is positive 3, so I should be looking at an upward facing parabola that's narrower, not only than the parent function, but even narrower than the function or the quadratic function we just graphed, because that one had an a value of negative 2. So pause the video, fill in this table, graph your parabola, press play when you're ready to check your answers. So to find the y value of my vertex, I changed x to 1, so 1 squared was just 1, minus 6 times 1 is 6 plus 2, and then 3 minus 6 is negative 3 plus 2 is negative 1, so my vertex is over here. My next set of symmetry points were 0 and 2, and so 0 is going to be a really easy number to work with because this term will go away, this term will go away, leaving me with 2. And so I've got these 2 points, 0, 2, and 2, 2. And so the good news is this is starting to face upward, which is exactly what I wanted. I then chose to use negative 1 as my next symmetry point, and I knew that negative 1 squared was 1 times 3 was 3. Negative 6 times negative 1, be careful with those signs, is positive 6, and then plus 2, and 3 plus 6 plus 2 is 11, which went off my graph but by 1, so it wasn't bad. And so looking at this parabola, I can see it's upward facing, which I expected, and it is narrower than the graph above it, which is also good news. So let's get started on this axis of symmetry as well. So I'm going to have opposite b over 2a. And so in this case, since my b value is negative 2, that means opposite b would be positive 2. And then my a value is 1/4, so I'm going to do 2 times 1/4, which I could do that off to the side somewhere if I needed to. And that would be 1/2. So I'm dividing 2 by 1/2. And so then again, I can say 2 divided by 1/2 multiplied by the reciprocal, 2 times 2. My axis of symmetry is 4. So if I bring that over to this graph, here's going to be my axis of symmetry. So you're going to pick this up here by finding the y value of your vertex by replacing 4 into this quadratic equation. You're also going to build symmetry points on either side. Now you could choose to use, for example, 3 and 5, because those are symmetry points. I would just kind of try to recognize that if I take 3 and square it and then cut it into a fourth, that's not going to work out so nicely. So I might try to do numbers that if I square them, they'll be divisible by 4. It'll make it a little bit simpler for you. Remember, symmetry points just have to be equidistant on each side of 4. Some expectations for your parabola: you would expect it to open upward because 1/4 is positive, and you would also expect it to be wider than the parent function. So go ahead and fill in the rest of your table, find your outputs, start with the vertex, and then build your symmetry points. Pause the video, press play after you've graphed your parabola, and you're ready to check your answer. So in this case, when I replaced x with 4, 4 squared was 16, divided by 4 was 4, 2 times 4 was 8, so 4 minus 8 was negative 4, minus 4 was negative 8. And so my vertex is at 4, negative 8. I then chose 2 and 6 as my next set of symmetry points because I knew if I squared 2, 2 squared was 4, I could divide that by 4. So 2 squared was 4, divided by 4 was 1, 1 minus 4 was negative 3, minus 4 is negative 7. So that's my output here, and so those are these 2 points here, which is good news because my parabola is facing upward. It's also wider than the parent function. My next 2 symmetry points, since I already jumped by 2 and by 2 again, it made sense to me to make another jump of 2. Also, 0 is a really easy number to work with. If I replace 0, this will drop out and this will drop out, leaving me with negative 4. So the symmetry points of 0 and 8 had a y value of negative 4, which are here, continuing that upward trend and wider than the parent function. So the next thing we're going to do is we're just going to find the axis of symmetry in the vertex and then say whether or not it's a maximum or a minimum. So the maximum or the minimum is going to depend on whether or not it's a downward facing parabola or an upward facing parabola. Downward facing has a maximum, there's a highest that it reaches, and upward facing has a minimum, there's a lowest that it reaches. So to find our axis of symmetry, we still use that same formula, opposite x equals opposite b over 2a. So in this case, b is negative 2, so opposite b is 2, over, in this case, my a value is 1. So 2 times 1, and this would give me x equals 2 over 2, which is 1. So my axis of symmetry is x equals 1. So the next thing I'm going to do is replace 1 into my equation to find the y value of my vertex, and so that will give me x squared, which is, or 1 squared, which is 1, minus 2 times 1, which is 2, minus 3, and that would give me negative 1 minus 3, which is negative 4. So my vertex is 1, negative 4. Now for the maximum or the minimum, I'm going to take a look at my a value, which was positive 1. Since it's positive, that tells me that it's going to be an upward-facing parabola, which means that there's no limit to how high it goes, so it can't be a maximum. But there is this bottom part here, so it is a minimum value. And so the minimum value, not that it's asking for this here, but the minimum value would be just the negative 4 part. On example 5, you're going to do each of these steps on your own. You're going to find the axis of symmetry. Be sure to use the correct formula. Find the vertex. Remember, the vertex is a point. So axis of symmetry is an x equals equation. The vertex is a point. And then decide if the vertex is a maximum or a minimum based on which direction the parabola faces. Pause the video, press play when you're ready to check your answers. So in this case, my axis of symmetry would be negative 12 over 6 because of 2 times 3, which would be x equals negative 2. That's also going to be the x value of my vertex. If I replace x with negative 2 squared is 4, times 3 is 12. 12 times negative 2 was negative 24. 12 minus 24 was negative 12 minus 1 is negative 13. So my vertex is negative 12, negative 13. Since the a value is positive 3, that means it's going to be an upward-facing parabola, which means that the vertex is a minimum value. So now we're going to start answering some real-world questions based on a quadratic equation. So we have this formula, y equals negative 5x squared plus 200x, that models the height of a rocket, where y represents the number of meters high the rocket is going, based on the number of seconds, which is going to be our x value that it is in flight. So the first question says, how long does it take for the rocket to reach its maximum height? So remember, for any parabola or quadratic, which this is because it has squared, the maximum or the minimum is going to occur at the vertex. So they're really asking us something about the vertex. The other thing to realize is that our a value is negative. So that means that the path, not the path that the rocket itself is taking, but the graph represented height versus time is going to look something like this. And so its maximum height is going to occur here. So we're looking for that axis of symmetry. And so we're going to use our axis of symmetry formula to answer that question. So opposite b is going to be negative 200, because b is positive 200, over 2 times negative 5, which would be negative 200 over negative 10, which means my x value would be 20, because I can just cut off those zeros and 2 negatives and make a positive. So I can come over here and I can put my axis of symmetry. And so that means that it's going to take me 20 seconds for my rocket to reach its maximum height. Now, I haven't actually found the maximum height of the rocket yet. Remember, this axis is representing time in seconds. And so I found how long into the flight it would take for it to reach its maximum. Now, that maximum could be 200, 400, 600. I just know that it's somewhere at the 20-second mark. And so in order to find that, I need to find the second half of my vertex, which is going to mean to replace x with 20. So negative 5 times 20 squared plus 200 times 20. So 20 times 20 is going to be 400, and 200 times 20 is going to be 4,000. So I'm just going to 2 times 2 and add 3 zeros. And so this means it's going to be negative 5 times 4 is negative 20 plus 2 zeros plus that 4,000. And so that means the y value of my vertex is 2,000. So the vertex that I just found was 20, 2,000. And if I think about that as an ordered pair, 20 was my x value, and x is being represented by seconds. 2,000 is my y value, and that's being represented by meters. And so what this point tells me is that at 20 seconds, it will be at a height of 2,000 meters. And so 2,000 meters is the maximum height of my rocket. So I'm going to use that same quadratic equation from the previous page, which was y equals negative 5x squared plus 200x, to fill in this table. Now remember, my axis of symmetry was 20, which means 10 and 30 are going to be symmetry points. And so if I use 10, that means it's going to be 10 squared is 100, plus 200 times 100 would be 2,000. So that's going to be negative 500 plus 2,000, which would be 1,500 for 10 and 30. And so those 2 points are going to be halfway between 1,400 and 1,600. And then when I do the same thing for 0 and 40, the nice thing about 0 is if I replace x with 0, my answer is going to be 0. I've got 0, 0, and 40, 0. And so then when I graph my parabola, it's doing what I expect. It's going downward. And I don't need arrows here because I don't need it to go into a negative y. It's not going to have negative meters. And so it says use the graph to determine whether the rocket will reach the ground. So think about something that goes up and then comes back down. Its height when it reaches the ground is 0. So that means we need it to have a height of 0, which is here. That's when it starts. And then it has a height of 0 again here, which is at the 40-second mark. So it's going to reach the ground at 40 seconds. Next, it asks, when will the rocket be at a height of approximately 600 meters? So I'm going to go on here to 600. So I've got a point here at 600, so maybe that's 3 seconds. It's hard to say for sure, but it's somewhere between 0 and 5. And then it reaches 600 again, sometime between 35 and 40. Maybe that's 36 seconds. And again, it just said to approximate. And the reason it reaches it twice is because it hits 600 once going up, and then it's going to hit 600 once coming down. It's actually going to hit every single height twice going up and then coming down, except for the vertex that it only hits that one time. So the only time it hits 2,000 meters is at 20 seconds. That's the only height that it hits once. Every other height it hits twice, once going up, once coming down. So the last thing we have to do here is domain and range. So remember, domain is all of the possible inputs, which is all of our possible x's. And so if I look at the parabola on the x-axis, it starts at an x value of 0, and it ends at an x value of 40. So that means our domain is 0 can be less than x, which can be less than or equal to 40. So this is saying that the time the rocket can be in the air can be any time between 0 and 40 seconds. The range is all of my possible outputs or all of my possible y's, which is going to be the span on the y-axis. And so that's going to span from 0 all the way up to 2,000. And so my range would be between 0 and 2,000, written as an inequality. This says that y can be greater than or equal to 0, and it says that y can be less than or equal to 2,000.